Okay, well, in this double overtime video, I'm going to continue where I left off with the motor coil windings and add some of the conclusion to that and show where I am at now after the a couple other modifications and some of the comments on the video that I applied. These are finished up and dried. They're the correct value. I am pretty confident they're the correct size. They're wound in the same direction. And I'll continue on and describe how I got to this point with these, the adhesives I ended up using, the mandrels and mounts and the 3D printing and so forth. And I think they're pretty successful now, and I thank everybody that offered comments on these. They were actually quite helpful, so thank you for that. The second part, I received this tape from Jeremy over at the Weather Wolf, and we had some discussions about that, and I offered to test out his tape on one of my decks that I will calibrate to a known good tape, and I'll go through that with him. And then I also have a 122 Mark II transport only that was sent in for some various problems. The owner already did the recap on the motorboard, and he has some other issues here that I will get to, hopefully, if there's time, at the back end of this video. I'm trying to show the head here, but I'll have to do it in a different way. Okay, so getting back to these motor coils, if you saw in the last video, I had a very difficult time getting the mold to release the coil. And I tried many things in addition to what were in the video. None of them were very successful. I had some success, but you know, a third of them ended up looking like this, and that's really not that's not viable. Should be able to get everyone out of there without a problem. I don't know if I mentioned this is 36 gauge magnet wire, which is about 5/1000ths of an inch, including the coating, and that's about the width of 2 human hairs. So this is very fine, and it's not easy to work with. This method I actually showed some promise, but I have to find a different filament that is more brittle and will break off when I twist the 2 molds apart. But one viewer commented about leaving the core inside the coil, which is something I'd thought about previously. So I went with that, and I made a new form, or outside form, out of aluminum, and polished the flanges very highly. It did work. 3 or 4 did pretty well, and then they started sticking. And this is the last one I did before I moved on to a different material, and you can see that it just you know, it's still stuck on there. And I have my theories as to why this happens, even though I was using release agent. Again, 1 or 2, 3 would be fine, and then it would start to stick. and then it eventually ended up like this, and I moved on. It's actually very difficult to get anything to bond to aluminum raw like this without an adherent coating or that sort of thing, because it oxidizes instantly once it's machined. And that oxide layer is, of course, aluminum oxide, which is what a lot of our sandpaper is, and it's just very hard to get anything to stick to that for very long. Usually it requires, at very minimum, iodine, and that will be a short-term bond. Anyway, so then I moved on to copper, and this was a little bit more successful. I got several before it started to stick. It did not stick as tenaciously as the aluminum, or to the aluminum, but it did stick. And on this one, I didn't polish it. I left the tool marks in it, thinking that the release agent would have some place to kind of adhere. And, you know, I tried a bunch of different release agents, right down to paraffin wax, which actually worked pretty well. Then what I ended up with was going with just a pure Teflon. And this did work quite well, and I got 8 or 10 before this one started sticking, but even the Teflon started sticking. And like I say, I have my theories about why this is, but I can show you here that I'm using CA glue, and it looks like it started to eat away at the actual material, and that caused more mechanical grip. Although I could get this to release. In every case, I could get it to release once I figured out that I just had to give it enough time to cure up or set up and use the accelerator. And then I found if I just wrapped it against something to kind of jog it loose, it would come apart just fine. So this was successful. This worked out okay. And leaving the core in, I decided is actually a good thing, because it will give an additional, the little hole in the middle, the mounting hole, will give an additional place for the epoxy to mechanically bond to it. So I'm okay with this. I thought about it a little bit, and then after going through so many failures trying to get the core out, I just decided that it was, in my shop, it was going to be the only way I could really get this done. Another suggestion was printing these vertically so that the layers would be in the direction of the release, and that did work pretty well. The problem was with the vertical printing, the thickness was not as accurate. It was variable, and because of the way the flanges hold down on this core, the core actually needs to be pretty accurate in thickness, and it is very accurate when it's printed flat. But this is one of the bad examples. This is one I didn't use, but I did have some success printing them vertically, both from, you know, one side and then the other side. But there was also a lot of cleanup, and that's the direction of the layers on this, but there was a lot of cleanup on these that didn't have to be done with the flat printing. So that was a good idea, but printing flat was very simple. The brim just falls off, and all I have to do is deburr it slightly and put it inside the flanges, and wind it, and it worked pretty well. Okay, let's see if I can show you how they measured up. Now, while I was experimenting with all this, I sent an email to Permabond to see if I could get some advice on the correct bonding agent. And the rep contacted his engineering department, and they gave me 2 recommendations of adhesives that I required, my required specs. And so those are on order. I haven't got them yet, but they are on order. And basically it's going to be their 101 and 790 products, which are water thin wicking type CAs. And that's what I used here. It just wasn't a commercial grade. And there is a difference in commercial grade adhesives, believe me. The stuff that we buy in the stores is not the industrial. And I personally am a big fan of Permabond. I've had good success with their products for many years. Okay, so I'm going to run this up. I'm looking for around 13.5. It will probably go up to around 14 ohms at a higher temperature, but I think 13.5 is some of the lower ones I've measured, and so I'm shooting for that. I think I ended up with 237 winds to get to that. So this will come in right around that number. And they're consistent from one coil to the next. I don't see a lot of variation. The other thing I wanted to check for was leakage. And the way I did this is I put the coil inside of this aluminum jacket. And then put the ground lead on the jacket. I put a clamp on it to make sure it was in firm contact. I use the jacket as the ground and then feed it. I start out at the 50 volts. Now let's lock that. Okay, so there you see it's giving it 56 volts. Got no leakage. Let's take it up to 100. Lock it. You can do this for, 30 seconds to a minute, whatever. And I have done that. I'm just demonstrating here how they turned out. Here's 250, or it's feeding at 276 volts and no leakage. And to show you that. So I'm good with that. I have no doubt these will perform as they should. I might have to tweak the thickness just a little bit. I didn't have one apart here I did measure it before, of course, before I started, but I'd like to measure 2 or 3 of them and make sure I can actually get the same identical thickness on these. It's hard to measure when they're glued down to a board because you don't know what the thickness of the adhesive is. And so there's a little bit of guesswork going on there. Now what I made here was just a positioning fixture for if I need to install 4 of them. Even 1, it would be helpful. And then the way that works is this is actually upside down. The red ring will be down, and that will give a little bit of clearance for adhesive. And of course this will all be coated with the release agent. And that's the target for centering on the thrust bearing. And I probably should have printed that something other than white so it could show up on camera, or clear is actually what this is. So that would just be positioned and centered over there, over the thrust bearing, just like that. I've got to cut a couple of slots in this or not cut them, but redesign it to have a couple of clearance slots for the Hall sensors. But this is the idea. So I'd like to get these field tested, and I want to make the offer to send coils to anyone that might have some bad coils that wants to try these out, or send me the board and I will replace them and test it. I've got I think 3 sets of these ready to go here, and I'd be willing to send them out. I'll ship it back to you on my dime. I'll ship these to you on my dime. So if you're interested in testing these for me and maybe repairing your own deck that might have a unrepairable coil, contact me through the links here or my website, and we'll make that happen. Okay, so the second part of this one is the tape that Jeremy, the Weather Wolf, sent from Canada, and he was having some confidence problems with a tape he had purchased to check his speed and wound flutter on his machines. And I watched a couple of his videos, and he mentioned several times that he didn't trust the tapes. And so I posted a message to him and I said, hey, why don't you make a tape with your decks that you're questioning and send it to me, and I'll calibrate one of my decks to one of my known good tapes, factory tapes, and then I'll check your tape against those, and then you'll be able to have at least, a yay or nay. It's a good tape, it's a bad tape, but if there's a slight variation in it, then you'll know that. So he thought that was a good idea, and we said, well, let's just make a video about it. And or maybe I said that, but anyway, so that's what we're doing. We're just this is a confidence builder or a confidence destroyer, one or the other, however it turns out. And so this is transport. This is one of my own decks, and the transport was done probably a year or so ago, but it's a very solid transport. It's running generally around 0.03% wound flutter and very stable. And so this is a good one to test. And just to make sure, I want to just set my levels quickly. It really doesn't matter, but let's just do it. We're looking for 245 or 47, 245, I think, millivolts on those two test points. So this was pretty close. They look like they were balanced. I might have used a different tape to do these. Okay, that's good enough. It doesn't matter for a wound flutter tape, but since I'm here, I'll start out here with my old reliable RCA that's about on its last leg and needing to be retired. These tapes were not made in what anything looked like a cassette deck. These were recorded off shell in a machine that was very well built. I tried for years to buy one, and I did find one, but it was so cannibalized that I could have never put it back together. But this one has a lot of dropouts, and it has some spots where there's almost no signal at all. It's still good for speed, but it's starting to get really iffy to read wound flutter with. Okay, so Jeremy, you can watch the frequency right up there in the upper right corner. And then watch the percentage on the left corner. And I'm going to take whatever time I need here to really dial that into 3000 hertz as close as I can get it. In practical terms, it doesn't matter, but this is the concern that Jeremy had on his tapes and on his decks, and so I'll do everything I can to get this spot on for him. And I'll do both the fixed speed and the pitch control and try to get both of those in case I need the pitch control for any reason. I believe I thought I saw his Technics deck running at around 3014. I'm not sure, but I think that's what I saw. And so I expect to see 3014 with his tape on this transport if it's dialed in correctly to a 3000 hertz tape. Okay, I think I'm pretty happy with that. Okay, Jeremy, let's see what you got here. Looks like the first part of this is his Technics ASB 255. And it looks like I'm reading around 3005, 3004 hertz. And the other thing I'm seeing here is a little bit of out of phase. But it's running fairly stable there at around 3005, 3004. So not the 3014 I was expecting to see. But that's not bad. That's easily within tolerance. And then the second part of this will be his Akai Z9100. I know it's a Kai. I'm just overcompensating for pronouncing techniques correctly. Okay, let's get it over to the second part. And I'll go through here and I'll check the phase on this machine to make sure that it's his tape, not my machine. I didn't really pay attention in the beginning, just when I put the RCA tape in, which should be in phase. Okay, so your Akai is, 3001, 3002. Those last two numbers mean nothing in this situation. And this one seems to be similarly out of phase a little bit. I know that's a little bit concerning. I might want to make a correction on that. What I plan to do is record the last half of this tape on this deck at exactly 3000 hertz and send it back to him. So now the RCA tape's pretty close to in phase, even if I tap it around a little bit. So at any rate, the tape I send back to him, I want to have correct levels, correct phase, and I want it to be as accurate in speed and wound flutter as I can get it for him. So yeah, there you go. It's a little bit off. Now, I don't even know if you have an azimuth tape. I haven't seen you use that. I think you did, but, and of course this is 3000. It's not at the 10 or 12, whatever, but it shouldn't change. This should be in phase, and it should be in phase at 10 as well. So here's one of this is a reliable azimuth tape. Let's check it. Okay, let's just tweak that a little bit for him. Yeah, so there you go. You're almost 180 degrees out of phase on that. So you can reference on the one I send back to you. And again, it doesn't matter for the purpose of the other parts, but why not get it right? It never hurts to have us back up. Okay, and that's just, you can see that's just position of, exactly the position of where that tape is sitting in the well. And that's why I do like tape stabilizers, because they put consistent pressure on the tape. This machine didn't have that. I would sure like to find a way to maybe even make a accessory that goes in with the tape, just to keep them keep them similar. Okay, so there's yours. Standard sine wave. Up there around 3003. So I would say that you don't have a problem with speed. These are well within tolerance. I typically tend to run mine at about this speed anyway for most people, unless they're, professionals, and they'll adjust their own. But this is about where I like to run mine anyway, to compensate for different tape lengths, different tape stretch, different, all these different factors. Because they generally won't run faster. They will typically run a little bit slower if there's an issue. Okay, so my speed is still good. I'm not looking at anything other than the speed, the frequency up there in the right corner of the scope. And I'll go back and forth here while I'm doing this, and just constantly keep an eye on and see if my transport is maintaining its speed correctly as I'm flipping through these other tapes. Okay, so here's your Technics. Actually really close, but same phase issue there. So according to my tapes and my transport, your decks are running 3004, 3005. So I hope that helps you out a little bit. And while I've got this set up and the camera's running and doing these tapes and discussing about these things, I'd like to also do a real-time demonstration on why we can't make our own wound flutter tape, for example, and use that as a reference to measure our wound flutter on our deck. In metrology, we know that a machine can't be used to calculate or measure or calibrate its own error, and we know the reasons why that's impossible. And this is a good opportunity for me to demonstrate that in real time with a machine that's actually operating pretty well and is probably pretty typical of what other people might be using. This is probably a little bit better because it's completely overhauled and tuned up, but it'll still make the point fine. The more out of spec the machine is, the more easily it is to see the variation. So this is a brand new wound flutter tape that I purchased right from Sony when they were obsoleting all these, and I really haven't used it. I've been saving this one, and what you see right there for use is how much it's been used. This is hasn't even run one complete cycle yet. So this will be my base reference for this machine, and I've always called this one about a 0.03 wound flutter deck, and that's about what this new tape is showing. Speed wise, maybe a couple hertz slow. It might be because it's never been unpacked. It has never been run through all the way. It might be a little tight. Pretty close, very close. And you can see, unlike my RCA tape, it's very stable in terms of its amplitude. The poor RCA tape is all over the place now. It's probably got chunks of oxide missing. Okay, so this is my base reference. And Jeremy, I'm going to put in your tape next and record a 3 kilohertz signal on about the last half of it before I send it back to you. And you can see that it will be recorded at about 0.03% flutter. So those are the two tapes that I calibrated with, and your tape. And I'll try to also get this right close to 0 dB for you. Okay, pretty close there. Looks like on playback, I'm actually about half a dB high on the left channel. So just make note of that. Right channel looks to be right about 0 dB. There's the phase. Okay, so you can count on it being like that. Okay, so I'll continue with that, let that run out, and continue to make more tests. Now, the other thing I'll do here, of course, after I'm done recording this, I'll wind it back a little ways and play it now on the same deck that I recorded it. This transport we've shown is around a 0.03% wound flutter. And now we're going to play this back and test our wound flutter. Okay, so that's not 0.03, obviously. Now, over the years, I've read and heard a lot of numbers thrown about when doing this exact thing, recording a tape and then using it to test the deck's wound flutter. And I've heard the numbers 2 times. I've heard the numbers 1.4 times greater, 1.4 times less. I think that number came from the square root of 2, 1.414, something. And maybe it seems like that should be correct, but I'm going to make a bunch of tapes here and demonstrate that it's not correct. And I'll do it in real time, and then maybe even try to explain my understanding mechanically of why that multiplier doesn't work in this case. So what I'll do here is I'll record, in addition to Jeremy's, I'll record several other, maybe 3 other tapes, same way I did with his, and play them back, and I'll play them back several times, intermittently putting in the calibration tapes to demonstrate that the transport is still running the way it was set up. And then I'll show the Flutter numbers on these other tapes that were recorded, you know, all here within the past 20 minutes on this deck, and attempt to show how much variation actually exists. Now, trying to kind of come up with an analogy as to why this happens and why it's variable and random and mathematical formulas can't be applied to it. I think of tuning like a 12-string guitar or any instrument, a bouzouki, a mandolin that has a pair of identical strings that get tuned harmonically together. When I do this, or did it, I would find a pleasant frequency that they would resonate, and that was always a pretty much consistent thing on each instrument. If you tune the harmonics, pay attention to the resonant frequency, for a moment, they will be resonating at that frequency together. And then as the note decays, they will go faster or slower. And in real music, it doesn't matter because you're on to the next note or, you know, whatever. But it's not really noticed, but it is noticed if you just pay attention to the harmonics. And, you know, you have to stop the other strings from vibrating, of course, but if you just do those two strings, it's noticeable. And the same thing happens here. The tape has a resonant frequency, or harmonic, if you want to call it that, in its recording. That factory tape may have been recorded at, say, maybe 0.02 or 0.01 something, who knows, but it's not 000. And so there is a sine wave in there. The transport that it's being played in also has the same thing. It has a resonance. It has a sine wave, but it's not the same as the tape. And so they can interfere with each other. They can cancel each other out. They can magnify each other. And sometimes they can be in sync. The problem with it is, without a reference source, we never know which one it is. I don't know if it's fast or slow or the square root of 2, or there's just no way to know. And that's why it's important to have a reference to compare against. So I've made 3, I think, different tapes here, same way. And while I've been rattling on here, if anybody's been watching and paying attention and looking at numbers, you'll see that there's a lot of variation. Sometimes it's pretty close. Sometimes it's right on. Sometimes it's slow. Sometimes it's fast. Now, unfortunately, on this one, I was just going along making tests and throwing different tapes in and out and testing them, but my main camera filled the card up, and so the other one kept recording, but I'm going to show it because the results on the scope are pretty telling. So I was just randomly throwing in different tapes. These were all recorded on this deck within, 20 minutes of each other. And I'm playing them back. Now there's one that's pretty close. And I'm just throwing them in and out. There's another one that's pretty close to that square root of 2. And I'm resetting the scope on each one, so it's fair test. I think that's my control tape there because of the spikes. Okay, that is not the square root of 2. That one's kind of all over the place. That's pretty close to the square root of 2 there. About 0.41, 0.42 maybe. There's one here that's a little closer, but still a little bit high. Anyway, that's the point that I'm trying to make. I'm hoping that one or two of these at some point will actually show a lower number than where this deck actually runs, because it happens too. I've seen them so good in complementary sync, complementary error, that it's been actually down in the 0.01s in a deck that was operating around 0.03. So here's control tape again. I'm just going to keep doing this and showing these results. This can be duplicated on your own deck at home or whatever. And, you know, it just takes a few minutes to do it. Record a signal. Play it back a few times. Measure the wound flutter, and you'll see that it varies. So we can't... Okay, so let me grab one of my older homemade tapes. This was done on a JVC TD711, but it had a brand new, I had put a brand new TD, a V1010 transport in it, new motor. And this one was operating pretty consistently at 0.03 or lower. But the main takeaway is that it was a very consistent 0.03. There weren't many spikes in it at all. And see, right now, this one's showing a little higher than what it actually should be. This is how it is. And, you know, in metrology, we know that we can't use our machines to measure our machines. It just doesn't work that way. Okay, here's another one that I just made. I think this one was measuring in the 4s the last time I put it in. You can see the variation there. It just isn't consistent. That was a pretty short recording on that one. This is Jeremy's tape. Last time this one was in the 4s, mid 4s, I believe. Now this is looking pretty accurate. That's not mid 4s. That's pretty close to what the deck's actually running at. So there's a good example right there. Now, I need to tell you, Jeremy, where it spiked right there, that was where I thought I was recording on one of my tapes, and it was yours. So there's a 10 or 20 second segment in there that is bad. But there's still a good probably 20 minutes of recording aside from that. So be aware of that about midpoint. Okay, you can see the results. And again, left channel is about 5 dB higher than the, 0.5 dB higher than the right channel. Right channel came out pretty close to 0. Okay, here's another tape I made. I've measured this one a couple times. I'm doing this slowly to show exactly what I was saying before. So this one's going to measure slightly better than what the transport's actually doing. And that's how it goes. And it will go like this forever. It will be higher, lower, sometimes it will be correct. And I'm just going to fast forward through a few of these and keep doing it just to make the point, drive it home. And I was kind of having fun doing this too, so look at that. Look at the results on that one. So in other words, if I had a collection of these tapes here and I wanted to maybe not be so honest about it, I could do this and pick the one that gives the best results and show that. But you see that I always use the same tape in my tests. I never use my homemade tapes to show the results of the wow and flutter, the work I've done on the deck. I always use a reference tape. I could pick one occasionally that is better than what the results are, but that's not really very honest. Okay, there you go on that one. My V1010 transport. Pretty consistent. I think the reason why this one operates fairly close is, like I said, there was very little variation in that 0.03 number on that deck. It was consistent, and it was there were no spikes, there were no drops. So that tape's fairly good. This is the one I just made, brand new. I made a mistake on this. I should have actually packed this tape twice or at least once before I recorded it. I did record that whole thing. Now here's the Hans Peter Roth tape. I don't think I've actually used this one before. Now this will be completely different. This will be a DIN standard. And I'll probably slaughter these translations, but the reason I really like this tape is because he's written down the Berertet. I'm sure that's wrong. That's the rating. The Unbu is uncertainty, which is a really important number. And Besser or Beser, I actually guessed this one better than the 0.08%. And you can see it's complying with that too. So there's just one more comparison against known numbers. Okay, so let's go from here right back to the Sony. We'll switch back to NAB on this one. I think that's the most use I've put on this tape. And again, consistency. So not only is this a good number, but it actually betters the spec on this deck by a fair bit. Depending on whether you're going by the published specs or by the service spec, which is that 0.06 NAB, this transport is bettering that by a fair bit. And I find that to be the case in these when they're completely overhauled and they're blueprinted and tuned up. And there's modifications also that take place. But I can generally get these in that 0.03 range and sometimes better than that. Okay, so I hope that kind of let me explain a little bit about why I comment the way I do about not measuring your own machine with the machine. And let's move on to the next one. So part 3 of this video is 122 Mark II transport, just the transport that was sent in by Rod. And he had gone ahead and recapped the motor board and got it operational, but he was having some other issues with this. And we talked about it, and I said, why don't you send it in and let me take a look and evaluate it, and then we can discuss what to do from there. So the things that he described to me right off the bat made me think that possibly the head was out of alignment. Now the head had some bad scratching. I'll show that here in a minute. But initially, that was my first thought. So let's have a look at the head alignment on this and see if that's contributing to some of his audio issues. These are nice and open, and I'm going to do my best here to really show what I'm seeing when I'm looking for head alignment. And I think I can do it. But let's just take a look, number one, at the guides. And that is too high by quite a bit. You can see I'm kind of exaggerating this for the camera, but I'm showing you what it looks like. So that head is too high. The race head, on the other hand, is too low. And I'll show in just a minute here, it's not really that it's too low, it's that the plastic housing on these warps over time, and it twists as it warps. And I've seen this a lot. And it's a very delicate operation to get that lined back up. But I can show you right here, this one's hitting on the top. And the other one's hitting on the bottom. Right there. So that's not good. Yeah. So it's also tilted. I can see that immediately. Let me set the camera up here and show you exactly what I'm seeing. So I'm using just a white piece of paper, and I'm shining the flashlight on the piece of paper and looking at that gap. Just like that. And that's how far out of tilt. And that's also probably why that guide is hitting the gauge bar on the bottom, because it's tilted away from it. Okay, that's actually quite a bit. Let me show you the guide, how it's hitting the guide right about hang on. Yeah, I'll show you how it crawls up on that bottom guide. Right there. Just like that. Okay, so that's quite a bit. Okay, you can see all that. Let's move it over here to the erase head, and I'll refocus it and show you that. Okay, there it is in the erase head. You can almost even see the tilt. If you kind of compare it against the gauge block, you can see it's not at a right angle. And there's the tilt backwards. And again, that is warpage, shrinkage, and it just twists a little bit is what happens. There it is on that. I actually can't see this. I'm looking at the camera, the little tiny monitor on the camera. There's no way I could show you this and see it myself at the same time, but you could see it pulling away there. So here it is after about 30 minutes of working on that record or the erase head. These are very, very delicate to get fit back into place without going too far and then having to shim and do that sort of thing. So there it is, aligned correctly now. And the guides aren't interfering. Very simple there. Okay, go over to the repro and record heads. We'll refocus it. Okay, and there it is, parallel to the tape path. And no interference on the guides. This is easy. These have screws and they can be adjusted, but the erase head is a delicate sanding operation. I probably had it on and off 7 or 8 times, and I don't know of another way to do it. Okay, so now I've got it aligned. And I should have mentioned I didn't notice excessive wear in those heads. I only noticed the scratching. And of course the alignment. He had mentioned that he had scuffed up the idler tire a little bit. Of course, I'll change that out for him, but I want to leave it as it is so that I can duplicate the issues that he was having. Right now, I want to concentrate on these heads and try to show you what they look like. I know I really can't get in there the way I want to, but I can show you the picture that he sent me. And that's exactly what they look like. As bad as that looks, they actually aren't that worn. They just somehow got scratched. And of course, we're trying not to replace these if possible, especially since, you know, the wear factor isn't there. I think I can polish these out. And make sure there's no grit or grime before I start the polishing. I'll do these in place so I can evaluate it. I don't want to run any of my alignment tapes over this head in the condition that it's in, obviously. And I also notice it looks like he put some oil on the front bearing there, which is good, but there is no oil retainer there. And so I also don't want to run any of my tapes over the capstan and risk having the oil wick out into the tape. So I'll just do a quick cleaning on that. I'll run down into the shop and make a new oil retainer for it. At one point I had found a brand new factory Tascam oil retainer, and I measured it, and I just kind of duplicate that in a much better reinforced industrial plastic than what they had used. Most of these have fallen off, broken off. They shrink around that capstan, split and fall off. These, being a reinforced plastic, should last a lot longer. Push that back on there. Oh, too much. There needs to be some space between the retainer and the bearing. I'm trying to turn that without moving it out of camera view, but I'm not doing too well. Yeah, just about that much. It can be more, but at least that amount. Okay, while I'm here, I'm just going to completely clean that off with some IPA. And I'll also clean the pinch roller with the IPA while I'm here. And this will be one of my parts in my Dispelling the Myths video about IPA hurting rubber. It does not. It's a perfectly fine cleaner, and it does not dry anything out. So don't worry about that. Yeah, we better give it one more. This is just for the test. I'll naturally take this off and deal with it correctly. But right now I just want to test it and see if I can duplicate the issues that he was having. Okay. This is one of those don't do this at home kids moments. I don't recommend anybody polish their heads. I'm just showing you what I'm doing right now. This is the compound I'm using. A tiny amount, more or less just saturating the electronics wipe, or it's not a Q-tip, it's different than that. And I go about this like this very slowly and very carefully for about 20 or 30 minutes. Eventually, I get it looking like this, and under the loop it looks really good. All those scratches, the cross-grain scratches that were diagonal from the tape path, are gone. And fortunately they weren't horribly deep, so that saved this head out, or hopefully it saved it out. We'll make some tests, but I don't see any reason why it shouldn't be operational. Of course, I want to degauss it as well. And I've done this in other videos, and I sped through it and I realized that was not a good thing to do. This should be done very slowly. By the way, I'd be curious what anyone thinks of this gray carpet background. I normally work on a cork when I'm not filming, but I don't like the way the cork looks on camera. I love working on it, but I don't like filming it, or I don't like the way it looks. And so my other carpet, I think, is a good background, but it's too thick and it's just not good. This is a commercial tile carpet that I really like to work on. It's thin and very dense, but I'm not quite sure if I really like the background color. So tell me what you think of this. It looks to me a little bit dark. Okay, just check that. And that number 2 that you're seeing there is just ambient on the bench. And I'll show you that. I'll pull that away and show you that that's what I see all the time. See? Just blow off any of that dust and fibers that came off that swab. This transport looks to be in very good condition. Okay, I've got it installed in the same chassis that I was using earlier in the video for the other tests. And Jeremy, this is your tape running in this transport. Okay, so this one's got some good output, for whatever reason that is. looks like the motor's operational. It seems to be fairly consistent. Some of his issues were in frequency response, and I'm not too worried about the speed or anything like that right now, because he'll have to set that up on his own chassis. I will eventually set the speed, but he'll have to just make a fine correction on it. But what I'd like to do here is make sure it's operating correctly. And consistently. And that's not too bad at all. Okay, let's do some frequency response tests. Before I do that, I want to make sure that the azimuth is correct. And I do this with a preliminary tape like this, so I don't have to spend so much time on my good tapes. Just make a coarse adjustment with this one. You can probably see why I like using this instrument to do this job rather than an oscilloscope. But I have the scope running up above this. I'm watching that too, but my main focus is on the sound technology. Okay, here's my reference tape. Sneak up on it. Okay, good enough. Now I need to align the record head to the repro head, and it's not too far off. This isn't bad. I think I can get a little better than this. And of course, this is doing it at 4 different frequencies at the same time. This is almost just it's not even turning, it's almost like a tapping job. We're getting there. A little bit too far. If I go past where I'm trying to get to, I back it off and then always work it in clockwise so that I'm tensioning the spring, not detensioning it. So I'm always working in one direction. Okay, we'll just set the low frequency at about 400 hertz. And here's the initial test with no adjustments on anything. Now, Rod, I think you tested this at 0 dB. The traditional thing for this would be at minus 20 dB, and that's where I'm at now. And so your high frequency drop-off was more than it should have been, but it's not incorrect. but this is just base internal settings here. And we'll work on that. Of course, the nice thing on the whole 122 series is the external controls for bias and levels. And it's makes it nice to work on somebody else's transport because I don't have to change my internal controls, my internal pots. I can just dial in the external ones. Just quickly go through here. I don't need this perfect. I just need to see if I can get a decent frequency response. Of course, I had that turned up way too high. Okay. That tells me right off the bat, those heads are serviceable. This is type 1 tape. I expect minus 3 dB, somewhere around the 16 to 17 kilohertz area. No problem hitting levels, and no problem hitting the bias either. I just need to get it close. Okay, a little bit more under bias tweaking. I'll just do it by feel. That was too much. Way too much. Okay, this is playback. Again, I'm going off of the playback, not monitoring the recording. This one will look pretty good. There it is. So, Rob, I'm pronouncing your heads fit for use. No problem there. I'll take a look at some of the other parts of it. And, of course, I'll change that idler tire out. And then I'll send you an email, and we'll go from there. So anybody that made it this far, I do appreciate it. I know this is a long video, and I know I did 3 in 1, but I've been really pressed for time lately, and this was a way I could get everything I needed to get done video-wise and still maintain the rest of what I need to do. So stay tuned for some more 122 Mark II videos in hopefully the near future. I've got some modifications and some things I'd like to show there. And I hope you all enjoyed this as much as I enjoyed making it. And as always, thank you for watching.